Now let's do a second example for balancing reactions. Say I have this molecule and these are the reactants, and my products will be okay, these complicated molecules. So the trick here is to try to look at which molecule has the most atoms and start from there. So I'm going to deviate from that a little bit, because if I look at this molecule, I have cobalt and sulfur atoms. I have 2 cobalts on the right, 3 sulfurs on the right, but I only have 1 cobalt on the left and 1 sulfur on the left. So I'm going to balance cobalt and sulfur. So to do that, I'll put a 2 in front of the first molecule, so now that'll give me 2 cobalts. I'll put a 3 in front of the second molecule, that'll give me 3 sulfurs. So now this is balanced. So now the second thing I want to try to do is balance this next, because it has nitrogens and oxygens. By adding the 2's and the 3 in front of the first 2 molecules, that's going to change the number of nitrogen and oxygen. So I'll just pick nitrogen. So on the left side of the equation, I have 6 nitrogens for the first molecule and 6 nitrogens for the second molecule. That's a total of 12. So I'll need 12 nitrogens. So on the right side, this molecule has 2 nitrogens, so if I put a coefficient of 6, that'll give me 6 times 2 is 12, 12 total nitrogen atoms. Now my equation should be balanced now. I've added coefficients to each species except for this one, and I used it to balance the left side. So now let's check oxygen atoms. They should be balanced because we can't create or destroy oxygen atoms, but let's check. I have 3 times 3, so that's 9 oxygens on the left. I have times 2, so I have 9 times 2. That looks like a 90, but it's 9 oxygen. So 18 oxygens on the left, so I should have 18 oxygens on the right. So 6 times 3 is 18, so that's right. 6 times 3. So now let's look at hydrogens. I've got 8 times 3 is 24 hydrogens on the left, and I have 6 times 4, 24 hydrogens on the right. So this equation is now balanced.